So the last thing is going to be what about when it's normal to a curve? All right, well, we need to know what that word normal means. A normal line means that you need to be perpendicular to the tangent point. So we need to know information at that tangent point. There's a couple things. Where is that tangent point? And then what's the rate of change? What's the slope at that tangent point? All right, so what we're going to do is we're going to write an equation for the normal to this curve, which our curve is 4 minus x squared, at that specific x value, x equals 1. Okay, well, first off, that's the question. We need to know normal. Okay, normal means perpendicular. Okay, well, wait a minute. We're going to be perpendicular to a tangent line. Perpendicular means that if we have a tangent line, we have a slope. All right, well, perpendicular means opposite reciprocal slopes. So I need to know the opposite reciprocal slope to the tangent slope. That's the first thing. If you ever says you need to be normal, you know you got to be perpendicular. Perpendicular deals with opposite reciprocal slopes. I better find a slope. Well, I'm probably going to have to use the limits in order to be able to do that. Because if you look, I only gave you one x value. All right, so that's what this next part is going to be. Next part is going to be us actually going through and finding, well, what is the slope at that specific tangent point? All right, well, remember my original function is 4 minus x squared. I'm going to go through this process again. X plus h is my new function. I got to plug that in. I got to do some distributing, some multiplying, some algebra. You can see what I'm doing throughout all this stuff. Hopefully this makes sense. So at this point, I'm going to stop. I'm just going to explain. My first function, f of x, is 4 minus x squared. My input is x. My output is 4 minus x squared. Remember, I got to change it. I got to create my second point. My second point is add some distance to the x value. So add h to x. Well, whatever operations I do to my original function, I got to do the same thing to this new input. So you can see it says 4 minus x being squared. So that means I got to do 4 minus my new x value, which is x plus h being squared. So I took my x plus h, I squared it, got x squared plus 2x h plus h squared. I distributed the negative through, so it becomes 4 minus x squared minus 2xh minus h squared. This is key. Lots of mistakes can happen at this point. Be very, very specific. Be very, very critical with how you do your algebra skills. The biggest thing that people, I'm not good at calculus. No, you're not. You're not good at algebra. And if you're not good at algebra, yeah, you're not going to be good at calculus. So we need to be good at with our algebra skills. All right, so now here comes the next piece. Well, now let's find the slope at that specific tangent line, at that specific point. Well, that means we're going to take a limit. So the definition says take the limit as h approaches 0 of f of x plus h minus f of x, divide that by h. Well, that means I'm going to take 4 minus x squared minus 2xh minus h squared, and I'm going to subtract my original function. Once again, algebra, you're subtracting 4 minus x squared. You better put that inside parentheses, and you had better know that you're subtracting both of those. The thing that's going to happen is people are only going to subtract the 4, and they're going to still leave that as a minus x squared at the end. Wrong. That's bad algebra. Oh, I'm not good at calculus. Yes, you are. You're horrible at algebra. You just need to better your algebra skills. If you can improve your algebra skills, you're going to be gosh darn good at calculus. All right, don't forget I'm dividing all that by h. All right, so at this point, you can see that we're going to go ahead and eliminate some things. The 4 minus 4, the negative x squared, and that positive x squared. I'm going to go ahead and eliminate those. That's really a positive x squared at the end because I'm subtracting the negative. I'm getting rid of that stuff, and now my limit as h approaches 0 is negative 2xh minus h squared all over h. Once again, do some more algebra. Simplify, okay? Get rid of those h's. Now my limit becomes, as h goes to 0, of negative 2x minus h. But once again, h is approaching 0. It's approaching a minuscule number, an extremely small number, which means nothing. So really, minus h means minus 0. I'm left with negative 2x. That right there, when we finally are finished with our limit and we have actually plugged in that value, we don't have to write limit anymore. Every single step up to that point, we have not taken a limit. All we've done is algebra, 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 algebra. Now the calculus piece, we plug it in there. We actually find the limit. We actually evaluate the limit. So this limit is actually negative 2x. Now, that is not a slope. What that does is it helps us find. It's how we can find slope at any point along the curve. That's how we find slope at any specific point. So in this case, our specific point was at x equals 1. All right, so the slope at x equals 1 is just negative 2 times 1, which is negative 2. So now we actually have a slope. Perfect. So the first thing that we wanted to do, we wanted to write this normal line. Well, in order to write the normal line, we need a slope because we got to have an opposite reciprocal. Well, we just found the slope that we needed to use. The slope at my tangent line is -2, which means now we can find the slope for my normal line, the opposite reciprocal slope. So now, when we come over to this next piece, you can see the normal line, it's our perpendicular slope, perpendicular to our tangent line. Well, we went through all that big process just to be able to find that slope. Fortunately, right now, that's what we have to do. So normal line, perpendicular to the tangent slope is -2. My normal slope is now 1/2, opposite reciprocal. Opposite, change the value, change the sign from a negative to a positive, and then flip the fraction. All right, well, the other part is, well, what about the point? If I want to write a line, I need not just a slope, I need a point. Well, remember, they gave us that point. They didn't specifically tell us the y value, but they did give us the x value. So x is equal to 1. My original function was 4 minus x squared. So I need to find f of 1. All right, so 4 minus 1 squared, f of 1 is equal to 3. So now I actually have a point. So if I want to write my normal line, I've got my point, which is 1, 3, and now I've got my slope, which is 1/2. And now you can write your line however you want. I'm going to write it as y minus 3 is equal to 1/2 times x minus 1. You could add the 3 over. You can distribute the 1/2. You can do whatever you want, but this is it didn't say a specific way to write the equation of the line. It just said write the equation of that line. Write the equation of the normal to that curve. Well, we just did. So remember, if you need a normal line, you need the slope at the tangent point, and then you're going to take the opposite reciprocal of that tangent slope. And then you also need to have that point.